Okay, this is 1.4 part 2 and 1.5. We're just going to start with example from 1.4, example 4. And we did function composition. Now we're going to do function decomposition. And I know that h of x is equal to f of g of x. For both of these, part A, I'm going to give h of x is equal to x plus 1 squared minus 3 x plus 1 plus 4. So I'm looking for what is my f of x and what is my g of x. G being on the inside, I'm looking at g here as being this. So g of x being x plus 1 is plugged in for the x in x squared minus 3x plus 4. So x plus 1 replaces those and I get my h of x. Kind of working it backwards and thinking about working it backwards. This is commonly used in calculus. For the second one, h of x, there's a few different options for this one. There might be other options for the first one, but I don't know what they are. Be a little harder. So option 1 here, f of x equals, and again, g of x is on the inside. G of x here is equal to, I'm going to say it's x cubed plus 1, and f of x is square root of x. And to me, that's the easiest option. Option 2, here g of x, there was my g of x there. Here g of x, I'm just going to say is x cubed, leaving me with f of x being square root of x plus 1. X cubed goes in for that x, and that gets me this. Both are reasonable options. Neither one is terribly difficult. Looking at example 5, modeling with function composition. So, in a medical procedure known as an angioplasty, doctors insert a catheter into a heart vein and inflate a small spherical balloon in the tip of the catheter. Suppose the balloon is inflated at a constant rate of 44 cubic millimeters per second. Find the volume after t seconds. Okay. Example 5, number 1, the volume after t seconds is simply V equals 44t. You get 44 cubic millimeters per second. And I guess that's A. This is part A, not number 1. Okay. Part B asks me to, when the volume is V, what is the radius? So V, this is a spherical balloon. V is 4/3 pi r cubed. So wants me to solve for V. I'm going to start by multiplying both sides by 3/4. So here I multiplied by 3/4. And then I'm going to divide this next one by pi, which is multiplying by 1/pi. So here I've got, let's go back to blue. 3v over 4pi equals r cubed, and r then equals the cube root of that. And the next question is, write an equation that gives the radius as a function of time. That means I'm going to plug in 44t for v. Three in for v goes 44t. And then over 4 pi. Because I can, I'm going to simplify this. That's 44 becomes an 11. R equals cube root of 3 times 11 is 33t over pi. It's my radius. I plug in 5, because it asks me for what is it after 5 seconds. I get 33 times 5 over pi. The cube root of that is 3.74 millimeters. Okay. Looking at a relation or an implicitly defined function. An implicitly defined function or a relation is a function that's not in y equals form. Okay. So it might look like this. This is going to be example 6. X squared y plus y squared equals 5. This is an implicitly defined relation or function. This one, we're checking these ordered pairs to see if they work. Oops. 2, -5, 1, 3, and finally 2, 1. If they both work, this is not a function because 2 goes to 2 different numbers. So to check if they work, I plug them in. 2 squared times -5 plus -5 squared equals 5. 2 squared is 4 times -5 plus -5 squared is 25 equals 5. -20 plus 25 does equal 5. Check mark on the first one. Let's try the second one. 1 squared times 3 plus 3 squared equals 5. 1 squared is 1 times 3 is 3 plus 9 is not equal to 5. So this one is a no. My third one, 2 squared times 1 plus 1 squared equals 5. That's 4 plus 1 does equal 5. Both 2's work. This is not a function. Okay. So we can check points by plugging them in. We can look at how to graph things. For an implicitly defined function, first thing I can look at is how to find this or solve it. This one is nice because this factors into x plus y squared. So if I'm factoring it, multiplies to, well, x squared multiplies to y squared. X multiplies to x squared is x and x. Multiplies to y squared is x and y. Adds to 2xy is xy plus xy. Remember that if I'm reversing my foiling, I have to FOIL the binomial. X squared plus xy plus xy plus y squared. X squared, xy, yx or xy again. And xy plus xy is my 2xy. To solve this, eventually I want to solve for y. I'm going to square root both sides. So I'll write that in here. when I impose the square root on something to solve, I must add the plus or minus. And to solve for y, I'll subtract x from both sides. Giving me two different equations here. Y equals negative x plus 1 and y equals negative x minus 1. Both of those are nice and easy to graph. Y-intercept of 1, slope of negative 1. Here is this one. Next one, y-intercept of negative 1, slope of 1, or of negative 1. Here's this one. This implicitly defined relation, this is a relation, this certainly does not pass the vertical line test, is a pair of parallel lines. I could say that's two implicitly defined functions. Either one works. Okay. So that is the end of 1.4. You're going to deal with some function decomposition and some implicitly defined things. For 1.5, we're going to talk about parametric equations or relations defined parametrically. Okay. Most of you are in physics or will be soon. One of the, or soon enough at least, I hope. Everybody should take physics. Physics is wonderful. One of these particular applications of this is projectile motion. Okay. And parametrically defined relations, usually you're used to x being your independent variable and y being your dependent. Well, in parametrically defined, t for time is independent. X and y are both dependent. And you will, t, your independent variable, doesn't appear on your graph. So I'm going to give you, here's an example of parametric equations. X equals t plus 1, y equals t squared plus 2t. So what I'm going to make here, instead of an xy table, I'm going to make a txy table. And I'm going to apply these following t's. Usually you want to put t-bounds on here, and generally t is probably whole numbers, but I like to define t. So part of your parametric equations, oops, that's not a very nice 3, is the restrictions on t. So it's two equations. Let me clean up this negative sign too. T goes from -3 to 3, and your restrictions on t. Usually, when I make my txy table, I just go by ones. So I can plot this in. To get x, I just plug in -3 into the x equation. So that is x equals -3 plus 1. That's -2. -2 plus 1 is -1. X equals -1 plus 1, 0. We can see the pattern. We're just adding 1 to all our x coordinates. Y, on the other hand, is a little tougher. -3 squared is 9 plus 2 times -3. 9 plus -6 is 3. -2 squared is 4. So again, I plug in t, not x. -2 squared here is 4. Cleaning up this equal sign. Plus 2 times -2 is 0. -1 squared is 1. Plus 2 times -1, that's 1 plus -2 is -1. 0 is 0. 1 squared plus 2 times 1, that's 1 plus 2 is 3. 2 squared is 4, plus 2 times 2 is also 4, that's 8. 3 squared is 9, plus 2 times 3 is 6. 9 plus 6 is 15. So I'm going to plot these points on my XY plane. So each one is going by ones. So -2, 3. I'm going to need a 4 here too. -1, 0. 0, -1. 1, 0. 2, 3. 3, 8. 4, 15. And my graph looks like a portion of a parabola. It does not have arrows on the end. It does not go forever. It ends at these specific points because those are my boundaries. Okay? Sure, I could write a brain. I'm going to call it a rectangular. I'm not going to call it a function because they're not all functions, but a rectangular expression for this. How do I do that? Well, I take my equations. I'm going to put them on the next page. X equals t plus 1. And y equals t squared plus 2t. I'm going to solve one of these for x or y. Or I'm going to solve one of them for t. The easier one to solve for t is the top one. And I get x minus 1. And then I can plug that into my bottom one. Or into my y equation. So I'll try to simplify that. The shortcut on foiling this, it's x minus 1, x minus 1. The shortcut is square the first one, take the 2 and multiply them together. X times -1 is -x, and double that. So 2 times x times -1 is -2x, plus the last number squared, 1 squared is 1. So this equals, when I expand that out, x minus 1 squared is x squared minus 2x plus 1. And then I'll distribute on my second one and combine like terms. That is the rectangular version of this. Okay. We are going to talk about another one. We're going to use the graphing calculator for this one. But I'm going to write it up here again. This is similar, but stacked a little differently. So, yes, we could make a TXY table again. Or, this case, we're going to go to the graphing calculator. And to do parametrics, first thing I need to do is go mode. I'll clear all that history so you can see it down here if you need to. Press the mode button. Down here, there's a line that says function, parametric, polar, SEQ is sequence. We're going to use parametric and polar both in addition to your normal function this year. So I'm going to take my arrow, scroll over to parametric, hit enter. And then to get out of mode, I'm going to hit second quit. Now when I go to y equals, I can enter my parametric equations. My T button is just the same as the X. So that's my variable button, no matter which variable I'm using. And then I'm going to go b plus 1. Okay, there's a couple of things I need to do before I go here. Zoom. So I look at, when I go to window, notice that it's got this T-min, T-max. Remember, I started at -3. Need to use the negative button. And I went to 3. The T-step that it's giving me here by default is fine. I don't think I want my Y-max to be that high. I think I want it to be 10 and my scale to be 1. So now I'm going to graph this. Oh, that's a part of a parabola. It doesn't look like, I don't see the end, so I'm going to increase my X max. Let's try 20. So now when I look at this is almost just a sideways version of the other one. Because I simply, this being my endpoint, yes, it would be a closed dot, this being my other endpoint at 15,4. Basically, all I did was switch the X and Y equations. So all I'm doing is switching the X and Y coordinates from my previous table. Okay. But parametric mode allows us to do a lot of graphing and allows us to graph some things that are not functions with our calculator. Okay, that is the end of your lesson.